Hi there, my name is Mervyn Nalatambi with Intel. Today I'll be talking to you about disrupting the data center. Does that sound like a good thing or a bad thing?
Good thing.
Sounds generic.
I guess it depends is correct. Disruption creates innovation, so sometimes disruption is necessary. So that way we can think outside the box. Intel is really good about innovating products, but our customers drive us to make that shift happen very quickly. And as you see, the way the way the world is changing today because of the different use cases that we have makes us innovate things a lot better than we traditionally have. So as you well know, that you've probably seen this slide or a slide like this in many forms. We have more devices on in the cloud. More devices that we have puts a lot more stress on the data center, and I'll explain. So traditionally we had one PC, maybe one PC at work. Today we have multiple devices that we take to work with us, and each one of these devices are connected to the network. And on the back end, what that is doing is it's driving the data center requirements. It's basically growing out of proportion. So we need to figure out ways to actually manage this a little bit better versus using the traditional one server, one application, or one server, one database type infrastructure as we had previously. What we call this is the digital services economy. And what that means is our customers traditionally have had their own data centers and have created products in those data centers, for example, applications or database or mail servers, but these are single purpose type applications. The cloud provided us the ability to create different types of applications in the cloud. A good example of that is something like Square. Before, there were no ways of handling things like money. There was no way for anybody to take any kind of foreign, but the Square made it a lot easier. But the Square company don't want to really run a data center. They want to be able to take a service that's provided by a cloud service provider and create a service to the end customer. Netflix is another very, very good example, where they took media that was a traditional physical CD-ROM that we rented from one of the stores and put that online. And the media has gotten very, very good. I only use, I don't even have I was going to say VCR, that kind of shows you my age. I don't even have a DVD or anything like that. Basically, I stream all my content to the devices at home. So that's another way of using data that's out on the cloud. But what this does is it strives us to create devices specifically for those type of use cases. And a lot of our customers don't want to build and maintain data centers because they're very expensive, they're hard to make changes, and you have to continually refresh the equipment that you have in there. So what they want is a service, and that service is basically how we're helping drive the digital services economy.
Sorry, but this isn't a new thing. I mean, digital services economy, are you equating it to cloud, or are you equating it to more the term digital services economy, because that's just a natural evolution of companies going online, whether they're using cloud services or not? I mean, is the point of this to say that there's only going to be more and more digital, and so Intel's going to be there providing chips to
yes,
do that?
And the latter is the answer. So what we're doing is we're providing processors and equipment to actually manage that and manage it a lot better. And we're also creating point products. So before we offered one type of server, one type of processor. Now we're offering a suite of solutions depending on how the customer wants to actually use that. And I'll explain that as we move forward. Good question. So we've worked really hard with Dell to identify these issues and create solutions around the products, the cloud products, the customer products that we have out. And Dell has been very innovative in pushing us to drive these designs and make us think outside of the box. Don't think of it just as a traditional server. Think of it as a piece of equipment that can grow and shrink depending on the workload that you have. So that's one of the things that we've done. Partnering with Dell has been really, really great. A lot of the solutions that they talk to you about, their server solutions, their storage solutions, all their networking solutions, all use Intel processors at the very back end. And a lot of these are dependent on the actual type of workload. The type of processor selection is dependent on the workload that they actually use.
Can you give us an example of something that you've created or done that specifically Dell has suggested or forced you to do? Force may be a strong word, but encouraged you to do or done something.
Or the shift of the market has, I guess, forced you to...
Oh, very good question.
It's specifically Dell, because that's what we hear today.
Yeah. So one of the things that whenever we build a SKU of processors, if you go out and look at the number of processors that we have, we generally come out with SKUs of processors that address different product lines. So we come up with a 4-core, 8-core, 12-core, etc. Today up to 18-core. Sometimes that's not good enough. So for example, a cloud service provider, depending on the features of that particular processor, will tell us, hey, you've come up with this set of processor SKUs, but that's not good enough. We want these particular features. We want high frequency, low core count. We don't want any of the additional, we have additional security pieces built in. We don't want any of the additional turbo boost, for example, or hyper-threading built in. We just want a processor SKU that's unique to the workload that we're running on. And what they do is they drive us to create a processor, a special processor for that particular customer. And in the cloud services, that's actually quite common. We've come up with about, in the past 2 years, we've come up with about 20 different SKUs that address those particular needs for
Do you customize processors for Dell, or the processors that Dell suggests are available to any of your customers?
So both. So Dell, if they have a customer that has a certain requirement, we will make, depending on the quantities, there's a whole economic thing that goes around that type of solution.
Whether it's worthwhile, yeah.
Yeah. Okay. We have to make sure that it's worthwhile to produce that amount. And because it's not typically offered to everybody in the industry, because it addresses a particular need, we create a special SKU stack for that particular customer.
Build it in Qualcomm or Broadcom could, right? Because they're now building chips for switches and standard.
Yeah, so we have to be able to address all the needs, and we do love competition. Competition is a great thing for us. It makes, keeps us on our toes and makes sure that we are addressing the entire market as best as we can. And then we also have created different types of processors. So before it was just a Xeon processor, and now coming pretty soon we have a Xeon D that addresses small form factors, single processing. For example, if you have a workload that is a web type workload and you don't want it to be in a shared environment, the Xeon Z might be a good option for that. The Atom is another processor that we took from the consumer base and created a very low power consumption, good performance but very low power consumption that gives our customers the ability to choose the type of processor that they want. The Xeon Phi is another one. The Xeon Phi gives you up to 60 cores, so if you have something that is compute intensive, that was specifically made for the HPC market. They basically are using that particular product for very intensive floating point and highly threaded processors.
So our customers, vendors, the industry, they're driving additional technological adoption to these things, such as, originally the Intel VT and stuff along those lines, that drove and gave the virtualization industry what it is. But
yes.
Is there other types of technologies and such that are getting integrated into this that you guys are loading? You're saying for some of those specialized chipsets, you're actually pulling back features, but are there other enhancements that are coming forth that's come from the change in behavior of how people are consuming digital services?
Yeah, that's a very good question. So a big one, security. Everybody's concerned about security. We acquired McAfee about 3 years ago. Slowly we have learned from them, and we're starting to put security features into the processor. We have the ability to do encryption. basically offloading encryption processes using things like AES-NI and TX-NI to be able to offload that off the processor so that whenever you're doing encryption or decryption processes, it's not affecting the CPU utilization. Basically, it's offloading that. In the virtualization world with our network cards, basically we can offload data coming from a virtual machine directly to a network card. That way it's not going through the hypervisor and creating any kind of blocking or impacting any kind of performance.
So I have a question about the security features. So we're so basically you're offloading security features from being a general purpose CPU into special modules within your CPUs. How many backdoors do you have in the chips that we don't know about?
Way to softball him.
Well, yeah.
Good question.
Well, because that's an interesting one, because people can do security audits of software, but if it's in hardware and there's a backdoor in it, and it doesn't necessarily have to be you guys either. It could be someone else who makes a chip, not necessarily from this country.
Yeah.
I'm not from this country, so I care about that quite a bit. Although mine will quite happily. Mine's part of Five Eyes as well, so we're all screwed. So if there is let's say it may not even be an intentional backdoor, but what if there is something like Heartbleed in your chip? I can patch Heartbleed. How do I patch the chip?
Okay, very good question. So I'll give you an example of a security capability that we have called TXT, Trusted Execution Technology, and I'll explain how it works very briefly. Trusted Execution Technology has been on the Intel processors for, 7-8 years. And what we've done is whenever you start going into a cloud environment, you want to make sure that the hardware is actually trusted and the firmware that's running on the hardware is actually trusted. So if you can't trust the hardware, you basically can't trust the system. Trusted Execution Technology gives us that capability. What it does is whenever you activate it, whenever you go through a reboot cycle, it takes the machine down to running only a single process. Okay? So while it's running that single process, irregardless of if there is a virus or anything like that, there's only one process that that can run on that process, and that is a process that's signed by Intel. Okay? It will run on that process. It will validate that the firmware on that server is of a known good measure, and then it will start the processor. If it detects any kind of differential, any kind of change, it will alert the user, and the user will then decide on whether they want to actually continue booting that server or not, or remediate the problem that they have. So that's one of the solutions that we have.
So is that different from TPM, or is that a new?
Yes, TXT actually uses the TPM. The TPM has multiple registers. Their registers are available. Basically, you can write to them or you can read from them during boot and validate that server is actually secure. And then while it's running, if you're doing things like moving virtual machines from one server to another server, you want to make sure that the one that you're moving it to is also trusted. If you're dealing with entities such as governments or even financial institutions, they want to make sure that those workloads are only running on servers that are actually trusted in that environment. So that's one example. In the virtualized world, it gets quite interesting when you start talking about cloud solutions. Rather than taxing the infrastructure that we have on the security side, we have actually developed some capabilities to run small mini VMs off a security solution that address workloads in the cloud.
So operational ASICs that are running by the cloud service providers, essentially.
Pretty much, yes. Yeah.
So on the slide here, we say new internet services and cloud infrastructure, combined 600 billion. Is that all Intel revenue, or is that for everybody to get a piece of the pie?
Yeah, this is IDC data, and what they're telling us is 450 billion in new internet services. About 70% of that is consumer services, things that are developed by consumers, and the other 30% is enterprise. So enterprise is growing at a little bit of a slower rate than consumer. Apparently, the consumption of services, the consumption of devices is actually driving that capability.
The consumer level is driving enterprise adoption. We've all noticed that.
Yes. So of course more consumer, than enterprise. And then in the cloud infrastructure, that's a huge opportunity. That's lots of growth there. That's one of the reasons we're all here. Selfishly working for Intel. Intel has invested in many different companies over the past 2 years. We're getting real excited about all the Internet of Things. The Internet of Things is going to drive these capabilities even higher at a very faster rate. More data on the network. You'll be able to do more analysis on the data that you have. And this will have an impact on the data center infrastructure that is actually hosted. So today's infrastructure, very static, single purpose, generally mail server. I'm pretty sure you guys have seen slides like this. If you have a CRM system, it's pretty much siloed. You have one server, one system. And what we want to do is break that mold. We want to break the mold of having single purpose servers doing single purpose things.
But is that an Intel thing to fix, or Intel's providing a chip for virtualization / cloud to have multi-service functions? I mean, it'd be nice just to see what Intel's doing. I think we all get that data's changing. There's a huge amount of things. You want to have a lot of different things running on something. Yeah, how's Intel's handle it on that? Yeah. Because you do it already in a way. Intel processor runs on a Dell server, for example, which runs multiple virtual machines.
Correct. The idea is transforming the way we think and transforming the way data centers work. So one of the ways to do that is to change the type of silicon that we have and change the way we're using that silicon. Create processes, as I had mentioned in a little bit, create processes that are unique to the workloads that are being run, or change the box that we have. Instead of having a server that has dedicated memory, dedicated CPU, and dedicated storage, have pools. Why not?
Right? Kind of a software-defined compute, software-defined CPU model.
Software-defined infrastructure is growing at an enormous rate. We are contributing a lot into that whole ecosystem. And that's really the gist of where, addressing these limitations that we have on the network.
So shared CPU systems, shared memory kind of systems.
Yes. So that is what we see is the future. Now we have some customers that are looking really heavily into that type of environment. It may not be mainstream as far as enterprise mainstream because the ecosystem is not there today, but it's moving at a very fast pace, and we're helping a lot of our customers do that.
Do you have any sort of timelines on where shared CPU architectures may be available? I know HP's Memristor technology and their whole The Machine.
Yes.
I mean, they've said 2017, 2018. Is that something you're involved in?
Yes.
Okay.
So yeah, OCP is something that we've been heavily involved in from 3 or 4 years ago, actually, since the initial designs have come about, and we've seen some of our customers, especially our cloud service providers, embrace that type of technology. Now with that, of course, you have to have an orchestration system that is able to manage that type of infrastructure, because you have separate pools of storage, compute, CPU, and memory. And then you have to have the back-end infrastructure to be able to connect them together and create an environment where you can statically grow and shrink and create smaller virtual machines, if you want to call it that, smaller pools of virtualized containers that you can move around. So that whole ecosystem is growing really rapidly. The adoption is being, I guess that the first place that you can see that type of adoption is the larger cloud service providers. They're looking at that very seriously.
Do you foresee potentially running a hypervisor or a container directly on the chip?
That has been discussed. It is definitely an option, and of course the whole ecosystem, things like Docker has kind of opened everybody's eyes to containerized applications, and with that you can start to simplify the way the virtualization actually takes place. But yes, that's something that has been discussed.
Okay.
So what we want to do is disrupt the data center, change the model that we are working on. and basically create customization, create the ability to scale and shrink at at a desired rate, depending on the data center usage, depending on the cloud service usage, speed up the delivery. I remember when it used to take 60 days to get a server, turned on in a data center, just because the traditional things, that it was a server, then somebody had to install the operating system, somebody had to create a network for it, somebody had to do the storage behind it. We want to be able to do that in minutes, if not seconds. So today, virtualization addresses some of those capabilities, but you're limited to the box. Basically, it cannot grow outside of the physical box that it's contained in. In future technologies, what we want to do is expand that and make it more flexible, so you can shrink and grow a workload at will, and also address the network considerations, the storage considerations, and the memory considerations.
True compute fabric.
Yes. So the idea is making the application, okay, this is pretty interesting, making the application define the requirements of the architecture that it's running on. Okay, if we expose from the server perspective or from the hardware perspective, if we expose all the attributes, the power, which we're doing today, we're exposing power consumption, CPU utilization, IO utilization from the server itself. The application and the orchestration layer can then say, if I'm running a database and I need these particular attributes, whenever I create the container to run that database in, and it's using a pool service, do that automatically. So you can have that very, very quick container created, and it has all the attributes of the storage, the networking, the memory, and it can grow and shrink as necessary.
So because servers currently do that, obviously monitoring CPU and memory utilization, as more and more things and software and functionality is going onto the chip itself, you want to be able to provide that infrastructure monitoring directly on the chip.
That is correct.
Okay.
Yeah. So today we have, Dell has the iDRAC card, which we do a lot of integration work with. It talks to something called a BMC on the controller. And we now provide a lot of data to that BMC, and then it's exposed out through the iDRAC for management. Before it was simple things like power consumption. Today we can do things like capping. We can do things like looking at the server utilization from a hardware perspective, not a VM that's running on the server. So you can take a look and balance workloads based on the hardware that it's actually running on. So we've done capping. CPU capping is something that's quite new in the industry. Basically, what it allows you to do is, if you have a server that has multiple VMs running on it, you can migrate virtual machines to other servers if it's not, if you need to do an outage or if it's not being used, and then put that server into a lower power state to reduce power consumption. Yeah. So these are the things that we're addressing in the ecosystem to be able to make it very flexible and scalable.
Intel's obviously been, had a fantastic run rate with servers. I mean, pushing AMD towards the side. Cloud is obviously important, but the cloud is only one half of it. The consumer devices is what people are going to be connecting to the clouds. Intel has been seen as traditionally rather weak in running processors that run on iPhones and Androids and that kind of thing. Is that a growth area or something? I presume you're obviously looking at that.
Yes.
I mean, do you have anything to say about what kind of things you're doing?
So the Internet of Things has actually driven us to create processors. I'm not sure if you've heard about the Edison processor, the Quark, Galileo. Those are all, and then we came out here recently with something called a Curie. That is a little button PC. So those type of innovations, because of the form factors and the power consumption and the whatever can actually run on it, those are getting innovated into different types of sensors and devices that will connect on the internet.
So in a way, you may not be that bothered that ARM or other processors may be in mobile phones now, because when Internet of Things comes along, they're going to be a billion times devices, and if Intel's going to be in that market, well, mobile phones are going to be a little drop in the ocean of the
Well, we have actually gone into the phone market internationally primarily. We have Intel phones. Actually, the phone that I use is actually an Intel phone with an Atom processor in it. 2 generations old, but it runs Android really well. But yes, we've been one of the breakthroughs is getting the communications piece built into the processor, which we've done already, and there are designs out there today that are actually addressing that. And moving forward, we're definitely going to focus more onto the mobile phone handheld devices. Okay. So you'll definitely see that innovation happening. So one of the things with I know this slide is a little bit hard to read, but on the very left hand there, it shows you the data center, a typical data center that has no orchestration, pretty much a traditional data center. As we move down, what we can do is we can drive out costs of hardware, we can drive out costs of networking components by virtualizing them. Whenever virtualization came about, everybody said, whoa, hang on a minute, we're not going to touch that. You can't run two VMs on a PC or on a server. And look at where we are today. So the next iteration of containers or virtualization is happening in the storage. We've seen that. It's happening in the network. We've seen that. And of course, the virtualization now on the servers has become pretty popular. So now we can shrink and grow all these resources together to reduce costs of the different devices that we have. This is what Intel IT, this is what they've seen since 2010 to 2013. They focused on reducing the number of data centers that they actually support. And then they went multi-levels deep. The first one was consolidating the data centers and then creating a private cloud and then starting to do some orchestration internally and then starting to look at external cloud for growth and even savings. So as you go down the pipe, you'll definitely see the use of things like blade technology to increase the density of servers in a data center, but then decrease the footprint of the number of data centers to give you us and as well as our users a better experience and to be able to start offering cloud type services. So scaling, we've learned lots of lessons from the leading or bleeding edge. One of the things that you've seen is data centers have gone lights out. This has been happening more and more with the ability to do orchestration and remote management. We've gone light out. There's been a lot of analytics provided from the data center down to the end customer. So now they can manage things a lot better and they can make informed decisions based on the data that they have. Orchestration is everything. Obviously being able to manage the cloud, being able to manage all your resources and shrink and grow them as necessary is also a big thing. And then infrastructure failures. You can definitely address failures today. We've developed applications to where if they do fail, they're actually redundant. So not only have we built redundancy in the hardware, we've also helped the ecosystem build redundancy in the software and the operating system and the virtualization layers to be able to address failure and movement of components. Some of the trends you might have seen, containerized solutions such as Docker. Very interesting. There are pros and cons to having those type of solutions. We can talk more about that. Continuous integration and continuous delivery around software development. That is a very, very interesting trend to be able to deliver applications and to be able to modify applications at a faster rate. Rack scale architecture is something we're working very heavily towards. The ability to monitor and manage noisy neighbors, a very big thing. Actually, with our new generation processors, now we have a metric that will actually give you that from a hardware perspective. Open source and OpenStack, very interesting orchestration layers. Software-defined infrastructure, which includes software-defined networking, software-defined compute, and software-defined storage, all bundled into software-defined infrastructure. And then security components. I have a slide on what we're doing with a little bit of security from a software perspective as opposed to a hardware perspective. And then scale-out storage with things like Ceph, where you have distributed storage on devices that we have. Low-cost devices having distributed storage, giving you very fast access to your data. So we're actually investing in each one of these at different areas. So we'll talk about virtualized containers. There are pros and cons to having virtualized containers. With a traditional VM, you have the hypervisor, and on top of the hypervisor, you have your virtual machines. Each one of these virtual machines have an operating system in there that you have to patch and manage. Good and bad. It does give you some isolation. It gives you the ability to move these virtual machines across different machines if you had to. But of course, there's some overhead with the hypervisor. There's overhead with having multiple servers with multiple VMs on them. In a containerized solution, it's a little bit different, where you have multiple very small containers of applications running inside one operating system. So now your bottleneck is that one operating system. If the operating system goes down, your containers go down. So there are different ways to address these.
Is Intel doing anything specific for containers that would be different for VMs? Because I think most of us know the difference between containers and VMs. Is there a specific play Intel's doing for containers?
Yes. So what we contribute a lot into the open the open stack. Not only OpenStack, but also the open source that, applications. We have groups of individuals that actually contribute to the different areas inside that. Whenever we make a contribution, what we try to do is put in the hardware capabilities, build in the hardware capabilities so they can take advantage of that. Things like the AES-NI, it's a switch that you can actually turn on and on. TXT, same thing. You can address those, but we have to build the capabilities and then offer that into. So
potentially something like Intel VT. There may be an Intel CT for container something to do.
Yes. So as far as containerized solutions specifically, not. But the ecosystem that supports it, the networking, the security, the storage, all those basically we're providing. We're building capabilities and then offering that into the open source community.
Okay, so nothing specific for containers, but the underlying infrastructure.
Yes.
Adding more cores is totally an argument in that case. Just, yes, we're making chips with more cores, but I mean, it's just basically software. It's a kernel extension, right? It's hard to do something specifically for that, I think, other than just add more cores.
Exactly. We do support the whole, we have a suite of compiler tools, and that suite is actually growing to be able to support these type of solutions in the ecosystem.
In the same context, how, I noticed automation and orchestration, how does Intel play into that?
Okay, it's very, very same way with the orchestration layer. If you can take advantage of the hardware components that are built into the server, you can definitely manage them a lot better. So if you don't have a software capability to tie into them, then that gets abstracted from you. So we basically are providing that to the open community to be able to come up with these innovative solutions for
so you're
orchestration.
Opening up basically like APIs or.
Yes. Yeah,
nice.
And we did acquire Mashery too for API management. So we've been, as I mentioned, we've been doing a lot of things strategic to the cloud and the growth that's going to be out there with especially the Internet of Things. Yeah.
From an automation standpoint, you guys integrate in some way a relationship like Chef and Puppet, especially due to proximity of where they are versus where your headquarters are.
Yes. Yeah, very, very tight integration, and we contribute a lot into the open community. I know I have 5 minutes, so I'm going to go here really quickly. I'd like to talk about rack scale architecture. So this is an interesting area where we've moved from having discrete components to components that are pooled in a server. So this is very new in the ecosystem, and it's starting to gain a lot of popularity, where you have pools of CPUs. Instead of having a server with dedicated CPU, storage, memory, now you have a shelf, basically, that you can pull out and upgrade, and that shelf contains CPU. You have a shelf of memory, so you can upgrade the memory in that in that particular shelf, and then your storage similarly. And then in the back of these, tying these back together, you have to have a very, very quick way of moving the data from your storage to your CPUs, from your memory to your CPUs. So we've designed something called silicon photonics. Silicon photonics runs at 100 gigabit. It's a backbone that connects all these together. And what it allows you to do, instead of moving data basically north to south, it allows you to move data east to west to give you best benefit. So now CPUs can talk to each other. Multiple CPUs in a tree can talk to each other. Storage containers can talk to each other inside the storage shelf. So you go east to west in the storage shelf and north to south. So you're able to do both of those.
Can I buy this today?
There are certain vendors that are making different types of rack scale architecture. I'm actually working with a cloud service provider that has, they've had 3 designs. This is the 3rd design they're working on.
Okay, so it's commercially available?
Yes, but the cloud service provider has got to, they actually have to develop their software to actually run and be able to manage this.
It's only 100 gigabit between racks?
East-west?
Between layers?
Between layers. Yeah. So east-west is actually a bus. So you have a bus of and then that's just the backbone. That's 100 gigabit today, and that's going to be increasing pretty soon.
What's the latency on the 100 gigabit?
I don't know that right now.
Because that's bandwidth is sort of important, but latency is way more important.
Yeah, totally agreed.
Okay.
2 minutes. Whoa. This is
Do you have anything
really
regarding that you can talk about roadmap-wise?
Sorry?
Roadmap-wise that you can discuss with us? Do you have anything that
as far as rack scale architecture?
No, as far as what Intel has planned. Yeah, anything Intel.
Okay, so I can tell you, okay, we released our 2-socket E5 processors last year, towards the end of last year. So all the OEMs are creating products around that. Dell has done a really good job with us in creating products, the Dell servers on that. Our 4-socket servers will be, based on the E5, will be available towards the middle of the year. The 4-socket E7s will also be available towards the middle of the year. And then the Broadwell DE, which is a step higher than the Atom server processor, will also be introduced towards the first quarter-ish time frame.
Thank you.
You're welcome. And we have a really good suite of solid-state drives, which Dell is using in a lot of their appliances that we're announcing also. And the memory architecture is going to be changing. If y'all have been following on, we have been working very, very hard to change the memory architecture. Things are getting very, very tightly integrating into the processor to reduce the latency and increase the performance. So what you'll see in the near future is memory and storage starting to get very, very close to the CPU.
So on the SSD, is it going to be like a new S3700 or?
Yes. So there will be a couple of things coming out here pretty soon that will be interesting. That's all I can say. We're actually refreshing the S3700s. That whole line is refreshing. We're looking at 3D NAND technology. That's been out there for a little while. But the media is definitely going to be an interesting component of it.